Hi everyone. I think as we move into Tro Chapter 7, you'll start to gain an appreciation for all that you've learned in chemistry as you've put these atoms together to form compounds, and you've learned that language in Chapter 6. And now we're going to combine compounds and write chemical reaction equations, and it's such an efficient way of expressing a lot of information. In addition, you'll learn how to categorize chemical reactions, and that's in the second half. So this first half video is devoted to the format of a chemical reaction equation and balancing it. I'm just reviewing something that we've already covered from Chapter 7, which is how we have evidence of a chemical reaction, and you did a lab on this in the early part of the year, and we said we know we have a chemical reaction, meaning atoms are rearranging and bonds are breaking and reforming, if we have colors changing, or if we get precipitates, which is, remember, solid forming out of liquid, and if we have gases forming, and if we give off light, or if heat is emitted, or if it gets cold. Well, there's a format to reaction equations, and that is reactants are on the left and products are on the right, and we always have this arrow in between. And we're going to gain some skill in combining reactants to form new products, and we're going to work on balancing them. So that's the point of this video. First of all, let's remind ourselves of this phrase, bond axing is taxing, and that's an important energy change idea. When we have a chemical reaction equation, reactants come in with certain bonds to the atoms inside of the compounds, and these bonds have to be broken in order for the atoms to rearrange and make the products. Well, it costs energy to break up these reactant bonds. It's endothermic, energy consuming, but we get energy back on the other side as bonds form. It makes atoms more stable, and they release energy as they form new bonds. The net of this determines whether the overall reaction is exothermic or endothermic. And if it's exothermic, it would get hot, and if it's endothermic, it would get cold. On the bottom of this slide, you'll see the simple equation of two hydrogen gas molecules combining with an oxygen gas molecule to make two water molecules, and this is rocket fuel. It is therefore very exothermic. So in this reaction equation, we would get a lot more energy back as these products form. I want to note the form of this. These are our reactants, and this is our product, and we have this 2 that showed up. Now this is called a Now on the bottom of this slide is the rocket fuel equation, showing 2 hydrogen gas molecules combining with an oxygen gas molecule to make 2 waters. Given that it's rocket fuel, you know it's very exothermic. We get a lot more energy back when the products form. But I want to note that we have these 2's showing up, which we haven't had any practice doing this. These are called coefficients in contrast to subscripts. Now on the bottom of this slide, you'll see the rocket fuel reaction equation. Given that it's Now on the bottom of this slide, you'll see the rocket fuel equation. This is a chemical reaction equation. These are the reactants, and the water is the product. Now on the bottom of this slide, you'll see the rocket fuel reaction equation. Our reactants are hydrogen gas and oxygen gas, and our product is liquid water. We know this is rocket fuel, so it must be very exothermic. We get a lot more energy back as the products form than it costs us to break apart these two molecules. But I want to note something else about this reaction equation, and that is that these 2's showed up. And this is what we're going to be gaining practice with in this video. The 2 is a coefficient, in contrast to this 2, which is a subscript. It's really important that you differentiate between coefficients and subscripts. Subscripts are part of the compound whole number ratio of when the compound forms. 2 hydrogens go with every oxygen when a water molecule is formed. In contrast, this coefficient 2 says 2 hydrogen gas molecules combine with 1 oxygen gas molecule to make 2 water molecules. We're going to gain some experience in balancing reaction equation and placing coefficients. Before we start, let's go over some common abbreviations. In a reaction equation, you will see little g meaning a gas, little l meaning a liquid, little s meaning a solid, aq meaning aqueous, meaning this thing is dissolved in water. You also might see an upward arrow, which means a gas is formed, or a downward arrow, which means a precipitate forms. You also might see a triangle to represent heat. That will show up over the arrow, such as this. Okay, so let's go on. Let's consider the combustion of methane. Combustion means we're going to burn a hydrocarbon in the presence of oxygen. Here we have a gas grill shown. This is methane burning. Methane is CH4. Well, our reactants are CH4 and oxygen. And here's a case where I could use the little triangle.